Hello students, welcome back to the next module of a chapter called electromagnetic induction. Now students, in this particular module, we'll be discussing variation of inductive reactance and capacitive reactance with frequency, right? So let us start our module. Now students, for an inductor, I can say the opposition which is provided to a AC source, or rather I can say inductive reactance is given by the formula XL, it is equal to 2 pi FL. Right, where F is nothing but the frequency of AC source and L is nothing but the value of self-inductance. Right, now see carefully above formula. What is the relation between XL and F? I can say XL is directly proportional to the frequency. Right, now let us take this further. Now as XL, that is inductive reactance, it is directly proportional to the frequency. The graph between XL and frequency will be a straight line and it will be passing through origin. So let's say on x-axis will be marking frequency and on y-axis will be marking XL, right? And the graph between them will be a straight line which will be passing through origin. Why? Because over here XL is directly proportional to F. Right, now let's move further. Now up till now we were discussing with respect to AC source. Now let's say if I consider DC source. So for a DC source I can say value of frequency is 0 Hertz. Right, and as value of frequency is 0 Hertz, the value of XL will become 2 pi F into 0. Right, so therefore I will get the value of XL as 0. And thus I can say inductor does not offer any opposition to a DC circuit. Or I can say inductor will behave as a short circuit for a DC source or for a DC current or for a DC voltage. Right, now let us move further. Now we have discussed for inductor, now let us discuss for the capacitor. Now students, for capacitor, effective opposition or capacitive reactance which is provided by the capacitor to a AC source is given by the formula X suffix C, it is equal to 1 upon 2 pi FC. Right, what is F? F is nothing but the frequency of AC source. Capital C is nothing but the capacity of that particular capacitor. Now from the above formula I can say there is a relation between, or I can say there is an inverse relation between XC and frequency, and therefore I can say X suffix C, it is directly proportional to 1 by F, or I can say it is inversely proportional to the frequency. Now let us take this last equation ahead. Now over here, since capacitive reactance is inversely proportional to frequency, if we increase the value of frequency, the value of X suffix C will decrease. Right? Now let us plot a graph between them. So the graph between XL and F is as drawn in the figure. On y-axis again we'll take XC and on x-axis we'll take the frequency, and the graph between them will be like this. So for inductor it was a straight line passing through origin and XL was directly proportional to F, and in case of capacitor it is inversely proportional to F. So if we increase the value of F, XL will increase whereas XC will decrease. Right, now let's move further. Now students, for DC source again, frequency will be equal to 0 Hertz. So if I put frequency equal to 0 Hertz in the above equation, so what will I get? I'll get XC, it is equal to 1 upon 2 pi F into 0, and this will give me 1 upon 0 which comes out as infinity. So therefore XC, it is equal to infinity. From this we can draw a conclusion that capacitor provides infinite resistance, or it provides infinite opposition to the flow of DC current, or I can say it is blocking DC current, and that's why it is referred as blocking capacitor. Now what happens in this particular case? Whenever a capacitor is connected across a DC source, it gets charged, right? And till the time it gets charged, there is a current which is flowing through it. But once it gets charged, there is no flow of current through that particular capacitor. Right, now students, if I connect this particular capacitor in an AC circuit, then what will happen? The charging and discharging of capacitor will take place, and because of this charging and discharging, the direction of current in the circuit will be reversed. Right, and hence we can say there is AC current which is flowing in that particular circuit, and still there is no current which is flowing through that particular capacitor. Right, now let us move further. Now students, is there any difference between resistance and reactance? Now let us see what are the difference between resistance and reactance. Now first of all, On left hand side we'll have resistance, on right hand side we'll have reactance. Now students, if I say resistance, resistance is that property which consumes electric power as heat. And if I consider reactance of a pure inductor or capacitor, it does not consume any electric power, that is no heat is produced in case of pure inductor and in case of pure capacitor. Now second point, the resistance of a circuit does not depend upon frequency of an alternating source. It is constant for any voltage source. Whereas the value of reactance due to inductor and capacitor simply depends upon the value of frequency, because we know formula for XL and XC. What is formula for XL? It is equal to 2 pi FL. And what is formula for XC? It is equal to 1 upon 2 pi FC. And from the above formulas, we can say XL and XC, that is reactance, simply depends upon the frequency. So students, in this particular module, we have seen, or rather we have learned, the frequency dependence of the reactance. So that's it for this particular module. Till then, keep learning.